Hi folks, John Ricardo here. In this video, we're going to talk about verifying the continuity of your cable connection to your transducers or flow sensors. Very often when there's a problem getting the meter to operate, there could be a poor connection from your flow meter to your flow sensors, or maybe you didn't properly terminate the flow sensor cables and you have a short or an open. So this will address how you can very simply go about verifying the continuity of that connection and quite possibly fixing your issue. To get started, the only thing that you'll need to actually perform this check is an ohm meter. Pretty much any ohm meter will do. It needs just to read a few hundred ohms in most cases. So let's get started and take a look at how we go about doing this. To get started with this process, just simply access the flow meter with which you're having problems and remove the flow sensor cables from the flow meter itself. Leave the end connected to the transducers alone. With your flow meter cables disconnected from the meter itself and your ohm meter on and available, of course, do a quick check with your ohm meter just to make sure that it is responding, which it is. Then take one of your flow sensor cables and simply take one probe from the ohm meter and hold it against the outside of the metal part of the F connector, and take the other probe and touch it to the center conductor, making sure that you're not shorting out the probe to the F connector, and you'll get a measurement. So in this case, I'm reading 283 ohms, and I'm actually checking a D1H transducer, a D1 high precision sensor, and that is the correct reading for that flow sensor. At the end of this video, there'll be a table which will show you the two types of flow sensors, the universal and the high precision, and the ohm readings you should get for each size flow sensor. Here's a situation where we have a bad connection. So when we take the ohm meter and place it across the F connector, we still read an open. So that would mean that the cable may have a break, or it's not connected properly at the flow sensor end, or perhaps there was water infiltration and there was corrosion that took place, but that allows us to identify the fact that we have an open circuit. Here's a situation where the cable is actually shorted. So you can see we're reading 1 ohm, which is incorrect. That may likely be that when you terminated the cables on the flow meter end, a stray piece of the shielding got wrapped around the center conductor of the cable and is creating a short. So you'd want to go to the transducer end of the cable and inspect the connection. This is a simple test that you can perform and is very useful to catch poor cable connections, which are a primary source of failure for a meter to install. Again, here is the table that lists the two main types of flow sensors and the resistance values for each size that you should see when you measure using this technique. Don't forget that there will be a few additional ohms depending upon the length of your cables. The key thing is that the upstream cable and the downstream cable should more or less read exactly the same resistance value. Thanks for your attention.
Siemens, ingenuity for life.